Okay, so Anil, so we have been dealing with trigonometry, geometry, unit circle, circle equation, circle theorem, all those fancy stuff. So we wanted to get rid of the boredom that one unit brings, and we wanted to make sure that we get bored with the next unit, which is problem solving in data analysis. Okay, so we are changing the unit. Look, come on in. You had never seen the classroom before, right?
Yeah, it's my first
This.
time.
Come over, have a place for yourself. Sit down wherever you are comfortable. Just make sure that when we are talking, you guys are making eye contact and challenging me wherever I'm not making anything clear to you guys. Okay? All right. So far, Jenna had the opportunity of being behind the screen. Today, she is right in front of me. So yeah, I mean, I get super excited when I see the kids here in the classroom. Okay? I'm very happy with at least having two of you here. So we have Arush and Jenna, and Praneeth is a more frequent visitor, and then Davik, Sahib, Ananya, you guys are making the class complete. So let's get started. So we are starting with a new unit, problem solving and data analysis. So there'll be a lot of things that we'll learn as part of this unit, and this is, to be very honest with you guys, okay, you will not find a lot of new concepts. This is primarily around how do we do a recap of everything that we know, how do we relate to those concepts, and then apply it for the purpose for which these units are designed. Am I making sense to everybody, or I'm just blabbering? Okay. All right. So let's get started with that. And you all will not like what we will cover initially, okay? Hi, Sarah. We will talk about things that you have been knowing for ages. Ratio, proportion, and rates. And that will sound so stupid to all of us. Right? It's a very basic thing that even a fifth grader knows. But we are talking about the advanced level of it, where you will deal with the actual word problems, which will be little twisted in nature, and then how composed you are when you are solving it would make the difference. Pin drop silence. Everybody is thinking what to do, how to react. So this is something that Praneeth hates, many of you hate, and I know hate is a very strong word. But then this will be our savior for dealing with these kind of problems. Every problem that we'll deal with, we'll read, analyze, and then do it. That is the basic rule of thumb that you have to apply when solving any word problem. Okay? So let's get started. So first of all, let me hear from you guys. And again, whatever you know, you have to share. It's not about I don't think it is right, or maybe my definition would go wrong. What is the basic understanding of ratio and proportion that you guys have in mind? Go on. And yeah, Arush, keep the phone aside, beta, because I want to be your superstar for next 1 hour. Okay, what is the definition of ratio and proportion? How do you explain that to a third grader, let's say? I'm a third grader right now. Arush, don't be shy. Go ahead, beta, it's okay, perfectly fine.
I'm not sure.
So you guys...
I know a rate or proportion is something that you divide. Or it's like, say, apples to oranges or something. You can put like, say apples is 2, so you do like 2, and it's like, I don't know, something like that.
Yeah, okay.
And orange is like 3, so 2 to 3.
2 to 3. Okay. So that's what. See, you guys know it. I'm 200% sure you guys know about it. I'm wanting to see how do you articulate that understanding. Let's see what Ritika wanted to say. Ritika, go ahead.
Oh, I was just gonna say like comparison of like two things of like their sizes, like comparing like two things and like the number.
And that one word that you and Jenna said, that was ringing the bell for me. Ratio and proportion, these are the methods, or even rates for that matter, are the methods for us to compare. So when you talk about analysis doesn't hold a chance if you are looking at things in isolation. It's always a comparison. So all the things that we learn hereafter, you will see that nothing is looked in isolation. Everything is compared with something else. So ratio, proportion, rates, mean, median, mode, everything that we talk about, you will see that nothing is existing by itself. You are always comparing with something else and then you're dealing with it. Okay? So now, okay, fine. Ratio, you guys are saying that if I have, let's say, 2 apples and 3 oranges, so apple to oranges is 2:3. Or in fraction form, you can represent that as 2/3. Yeah? Everybody knows about it. Then what is proportion? We know a lot of things. When we share, that is where we get stuck. I'm trying to build you guys like a storyteller. Okay, what is proportion then? Anybody? And I'm trying to learn from you guys. I might be knowing it the ancient ways.
Wait, wouldn't proportion be like 2 separate things equal to each other? Right?
2 separate things equal to each other. Okay, no, I'm just trying to digest that. Okay, but I'm not questioning you. I'm just trying to digest. How do I interpret it? That's my goal. Anybody else? Can somebody tell me what is proportion? Riya, Samriddhi, Khushi, Vishal, Ritika, Praneet, Neil, Sarah, Ananya, anybody? Biswa? Guys, you guys are much younger than me. I'm wanting to see more energy from you guys than from myself. Yarush, what is proportion? See, I know you guys know it. I'm just trying to see how do you share it.
Like the ratio, but simplified.
Okay, Vishal?
It's like something that's like part of the other one. Like they're related, like they're like in an equal.
Okay.
Oh,
So
maybe it's like 2 ratios equal to each other. Is that what?
ratios equal to each other, that's the catch.
Eh?
Yeah, Vishwa, you're saying something.
Same thing, like a fraction or ratio equal to each other. That's what I was gonna say.
Exactly. So now I think you guys have decoded it. I've just borrowed that from you guys. If I'm talking about ratio, I'm comparing 2 things. It's my method for comparing 2 numbers. So if I'm talking about apple to oranges ratio is 2:3 or 2/3. If I say oranges to apple, this will become 3:2. Yeah? Whatever is your first thing. Or you can put that in fraction form 3/2. Yep. Now, proportion is an extension of ratio. Now look at it. This is one of the kids. I would have gotten a solid feedback from one of the child. Okay. So now let's look at we trying to bake. I know I'm not a great baker, but I'm still daring to bake. And somebody has told me that as long as your amount of flour, not flour, flour to sugar is 1:4. So sugar is to flour. Did I spell it right? This is flour, right? Yeah. Okay. So let's say if you want to make cake, a small cake, you need, let's say, 4 cups of flour and 1 cup of sugar. Okay? For a small cake that you are making, you need 1 cup. When you have 1 cup of sugar, you can have 4 cups of flour. So here, sugar to flour ratio is 1:4. Okay? Now you want to make a bigger one. So you want to make double the size of this cake. You will take 2 cups of sugar and 8 cups of flour. Yeah. Here again, so cup sugar to flour ratio, sugar to flour ratio is 2 by 8, which becomes 1 by 4. So here your ratios are the same. That's why when you're comparing two numbers with different quantities and your ratio is same, you see they are same proportion. Samriddhi, am I making sense better? And Samriddhi was not prepared. That this old man will put me on the spot. No, yes. I was just trying to make sure that no, everybody is with me. So ratio or proportion, these are same stuff. Primarily a tool for comparing two quantities. When you keep on changing your quantity and then the ratio between them remains the same, then we say, okay, this is the same proportion. So basically 1:4, 2:8, 3:12, 4:16. These are in the same proportion because their actual value or the ratio is same, or these are equivalent fractions. Making sense or no? Arush, Jana, Ria. So, and these are like jump start, okay? We are just doing a jump start. Ananya, okay, beta? Kushi, with me so far? And these are like wake up call, okay? I'm just waking you guys up after a heavy lunch. And then we'll get into interesting word problems relating to these concepts so that when we come across those problems and we hear these terms, ratio and proportions, and we start struggling to figure out what's the difference. So there is no difference actually. When you're dealing with same ratio for different quantities, you will claim that okay, you will not say this and this has same ratio. You will say that they are in the same proportion because their actual value, their ratio, the relationship between them is the same. Now what is the rate then? We talked about ratio, we talked about proportion, and now we are saying that okay, ratio and proportion are the same thing. When we are changing the quantity and the relationship between the ratio remains the same, we call it that they are in the same proportion. What is rate then? It's easy. You just have to see. I mean, if you have to lift weight, right? What do? You stretch your muscle a little bit. So I want you guys to stretch your neurons a little bit more and tell me what is rate. You all know it. And you will acknowledge that once I describe it. Ria, what is rate, beta? Describe it. You have to teach your teacher. Otherwise, I will mess up with everybody's plan. And if you guys need water or something, let me know. I can get some bottles for you guys.
Is a rate like similar to a ratio or a proportion?
It is similar to ratio, indeed. But there's a difference.
Is it like a percentage?
Not yet.
Oh.
Anything else? Now, you came to the class how? By car?
Mm-hmm.
What speed the car runs?
Like 45.
45 miles per hour?
Mm-hmm.
45 miles per hour. So on one side you had miles, which is a unit of length or distance. On the denominator you had hour. That's a different unit. That's a measurement of time. So rate is a scenario when you are comparing two numbers when the units are different. Now look at this. I'm reading 2 books per hour or 8 books per 3 hours. In the numerator, the numerator I have 8 books. And I'm taking 3 hours to read them. Again, I'm comparing 8 versus 3. But in my numerator, the unit is books. This is an hour. Same way, you buy vegetables, groceries, whatnot. It says $5 per pound. Dollar is a measurement of money. Pound is a measurement of weight. You go to Costco, you buy milk. It says 3.2 dollars per gallon. Dollar is a measurement of money, gallon is a measurement of volume. So basically you are using different units. Rate comes into play when you are dealing with two different units. So the comparison we were doing, let's say for that proportion thing, 1 cup of sugar versus 4 cups of flour, your units of measurement are the same here. So this is not rate, this is ratio, or when you extend it, it's proportion. But when you change your unit, okay, I drink half a gallon of milk every day. So half a gallon is a measurement of volume and day is a measurement of time. Yeah. So when your units are different across the numerator or denominator, or when the two things that you're comparing, right? I'm saying, let's say I get super excited to build, people build 6 packs, I'm building 12 packs. I start drinking 15 gallons of milk every day. I'm just making it up. So if I'm saying 15 gallons of milk, let's say not one day, I'm saying, okay, I'm drinking 15 gallons of milk in 3 days. So here also I have a situation where I'm comparing this number with this number, but my units for both the things are different. That is when it turns out to be rate. Yeah. So now people go to the market, what is the rate? Meaning you're saying, okay, what is the price per unit of certain things? Be it grocery, be it vegetables, fruits, buying gas in the gas station, right? $2.8 per gallon. You're dealing with two different units. That's when it is called rate. Yep. Does that keep the demarcation clear for all of you, or I'm still giving you guys reason to be confused? Everybody okay? So ratio, proportion and rate. These are the 3 very commonly used terms that we have dealt with, and my idea was not to teach you guys the basic concept. I know you guys are pretty much aware of it. I was just telling you guys how do you articulate what you know. That was the whole purpose. Now let's jump on to some interesting word problems and see how comfortable, easy, difficult it sounds. Yeah? Alright? So let's look at it. So let me go to the problems that I have put for you guys, and let's see how interesting or difficult it looks. The first problem I have here is, if y equals kx, I'm reading the problem for you guys, so we will see how relevant this one is. If y equals kx, where k is a constant, and y equals 28, where x equal to, what am I doing? Let me read it properly. If y equals kx, this is what is given, where k is a constant and y equals 28. Okay, here it says y equal to kx, k is a constant, and when y is 28, x equal to 12. This is the equation given to us. Okay, don't rush 1 minute. Don't rush. This comes here. Okay. Y equal to kx, when y equal to 28, x equal to 12. What is the value of y when x equal to 9? What is the value of y when x equal to 9? Now here this problem is an easy one. Very easy one. It says y equal to kx. So basically it's representing the relationship between y and x. Okay. And y equal to k times x, out of which k is a constant. Could be 1, 2, 3, 4, 1.5, 2.9, whatever it is. Okay. Then it's saying, okay, y equal to k is the relationship given to us. When y equal to 28, x equal to 12. What is the value of y when x equal to 9? So I would want you guys to solve it and also tell me how is this related to whatever preaching I was doing for initial 20 minutes. Everybody got the question, or you would want me to repeat one more time? We are given this equation y equal to kx, wherein k is a constant. When y is equal to 28, when x equal to 12. What is the value of y when x is 9? Yeah.
Is the only answer?
Yeah. Tell me the answer.
Y is 21 when x is equal to 9.
When x equal to 9, you are saying y is 21. I have one more question for you, but I would want you to share that with me after I hear from some more kids. Yes, Praneeth, what is your answer? Same? 21? Okay. And that only gives me part of it. Yes, Ritika?
I got 21.
You also got 21? Okay. And guys, be ready with your story, because I want to understand how is this equation relating to the three buzzwords that I was talking about: ratio, proportion, and rate. Biswa. So, for now, tell me the answer. Yeah.
What's the equation next to y equals 2x on the right?
Y equals 2x.
No, on the right.
Here.
Yeah.
So, let me read it for you one more time. Y equals to kx. This is a relationship given to us. Y is equal to 28 when x equal to 12. What is the value of y when x equal to 9? So you have to find out the value of y, and then I would want to understand from you guys, how is this question relevant to the topics that I was talking about? Riya, Neil, Sarah, Ananya. How about you guys? Khushi?
Wait, I have something.
Yes, brother.
I think they relate to each other because, like, one part.
I don't want everyone to get biased. I'll come to you later, okay?
Like,
So you got 21?
mm,
You'll be the one who will explain that to me, okay? So since you have started, I will let you explain. I just want everybody to give it a try, okay? I see everybody is quiet so far. So Khushi, Riya, Samriddhi, Neil, Sarah, tell me, beta, Ananya, are you all getting 21 or you got something else?
I got 21.
Okay. So now, yes, so let's assume, I'm assuming, Riya, did you get 21 beta or you got something else? Riya is angry with me. Neil, Sarah, you guys are angry with me too?
Sorry, internet kind of like.
Sorry beta?
My internet kind of like cracked, like, you know. So
Okay.
can you repeat the question?
We have an equation y equal to kx, where k is a constant, and then the next part of question says y is equal to 28 when x equal to 12. What is the value of y when x equal to 9?
Okay, thank you.
So, okay, Khushi, Ananya, Riya,
21.
tell me beta, 21?
I got, yeah.
Okay, cool. So I'm assuming that everybody got 21. If somebody did not get 21, if they do it carefully, they will get 21 only. Now Jenna, tell me beta. No, it's okay. Explain. Why? What is the relevance of this question with respect to the three topics that we're talking about? I'll let her complete. I'll come to you later. Okay? Yeah. Go ahead.
I think it relates because once you find one part, you can find another, so like it all connects.
Okay.
Like each part compares or kind of like equals to each other.
Okay.
You know what I mean? Like
No.
to find K, you need like first you have to find K, right?
Uh-huh.
And after you find K, then you can find Y when X equals 9.
Right. Okay.
It's because y equal to kx is a line, and since it's a line, there's a proportion for it. That means
Okay.
every time x moves up by 1, x times 7/3, which is k, equals y, and as a proportion that'll keep moving forever.
Right. So you guys are saying the same thing. Like Ayush, you mentioned, right? It's a ratio. Look at this. It says k is a constant. And what is k? If you want to keep k on one side, this will make the x move to the other side. which will be y over x. So y over x, this ratio is what is representing k. Or if you want to give k a name, that whatever is the value of y over x, that will be k. Let's say that is the, I'm not getting a good name, forget about it. So whatever it is, if in future y over x ratio turns out to be the way I would want to relate sugar and and tea, a flour, or sugar and tea for making tea, okay, then this ratio will remain the same. This is actually depending on proportion. No matter how much y and x you are fluctuating, as long as their y over x remains fixed or your ratio remains fixed, it's a proportion. So it's relating to ratio and proportion concept, right? So this k as a constant is nothing but a ratio. It's depending on ratio, okay? So if you are changing, so that's what is happening here. It's saying this is a relationship when y is 28, x is 12. So from this you will find that okay, 28 equal to k times x, 12. So k equals 28 over 12, which is 7 by 3. Yep. And if you want to play with this, play with this. 28 is 4 times 7, 12 is 4 times 3. 7 over 3. Yep. So this is the ratio. So here in this relationship you are seeing that x and y ratio is represented by the term k. That's why there is a relevance. Okay. I mean, I was just trying to see. I know this was not a very loaded concept, but I was just trying to say that okay, we are learning role ratio role ratio and rates, and then this equation comes from nowhere. What is the relevance? I mean, are you able to relate? Solving problems is easy, but more importantly, we have to always look at how do we relate to the concepts that we know, so that application of that becomes much easier. Okay. Now the next one, and everybody get some energy drink, Gatorade, whatever it takes. Okay. I want everybody to be with me, participate, fight, argue, discuss, disagree with me. Okay. That's how I enjoy math. Next question is, on an average, a commercial bakery bakes 800 blueberry pies. My English is pathetic. On average, a commercial bakery bakes 800 blueberry pies in 1 hour of baking. On average, a commercial bakery bakes 800 blueberry pie in 1 hour of baking. So 800 blueberry pies. Okay, I don't know if there's a slur around this one, but yeah, 800 blueberry pies in 1 hour of baking. Each blueberry pie requires 4 cups of blueberries. Each blueberry pie requires 4 cups of blueberry. Rounded to the nearest tenth of an hour, how many baking hours does it take for the bakery to use 30,000 cups of blueberries? Interesting.
30,000 or
30,000. 30, huh?
Which one?
30,000. 30. So I know there were a lot of words. Let me read one more time. On average, a commercial bakery bakes 800 blueberry pies in 1 hour of baking. Each blueberry pie requires 4 cups of blueberries. Rounded to the nearest tenth of an hour, how many baking hours? How many baking hours does it take for the bakery to use 30,000 cups of blueberry? One last time and then I'll let you deal with it. It says that the bakery uses on average bakes around 800 blueberry pies every hour. Every blueberry pie needs 4 cups of blueberry. Every blueberry needs 4 cups of blueberries. It says find to the 10th of an hour, nearest 10th of an hour, to find out how many hours will it take to bake this many cups of blueberries. Everybody got the question? This is a problem that even a 5th or 6th grader can do, but they have twisted the words a little bit so that it can match up with level for you guys. Okay, this is, if this question comes from the city, I'll not be surprised. It's a part of the city syllabus itself. So it's not about the calculation complexity, it's about how do you think about it, how do you relate the concepts, how do you apply it, and how much respect you give to the word problem. Yes, sir.
So how much do you round that?
I'm down by 10th of an hour. Okay, you got the answer. How much it is?
9.4 hours.
9.4 hours. Okay. Ananya, Khushi, Neil, Praneeth, Riya, Ritika, Samriddhi. Everybody got the question, right? Vishal, this one. Okay. I'll give you guys only 2 minutes for solving this. Or maybe 2.5. Jana, you got the question, beta? Okay. And you got 9.8 hours, right?
9.4.
9.4. I would suggest review those. Review the answer, okay? This is one very ancient way of doing maths.
Like 30,000 cups, right?
Yep. But during the class, try to avoid phone beta, okay? Not a good idea. Yes, Praneeth.
9.4.
9.4 hours approximately, okay?
Yeah.
Okay, I'm not saying that whether that is right or not. I want everybody to find their own answer. Ananya, Samriddhi, Viswa, Vishal. Yes, Ritika, go ahead, beta.
I got like around 9.4, but I'm not.
9.4.
It's like around like 9, but not like exactly.
Okay, yeah, I mean, we have to round it to the 10th digit, so 10th of an hour, basically. That 9.4 is okay. If you say 9.45, that is when I'll be concerned. You have to find to the 10th power. Yeah, Praneeth, you're saying something, or you want to raise it down, or bring it down, not raise it down. Jina, what's happening with her?
I don't know. I'm confused.
You never knew that I'll be bothering you so much after you come to the class, right? No, I just want to see how kids are trying it. And when the kids are here in the class, that gives me the extra ability to see if I can help. Yeah. Kushi, how about you, beta?
I'm working.
Working on it? Okay.
Sir,
Yes, beta.
what's that thing circled?
What's the thing circled? Okay. So I'll have to read the question for you one more time. So you know what the question is?
Yeah, but like I can't see the numbers.
It's 30,000. So I'll just give you a summary of this question, okay? It's talking about a bakery which bakes 800 cups of it bakes 800 blueberry pies every hour on average. And every blueberry pie needs 4 cups of blueberries. So it says how many hours it will take to use 30,000 cups of blueberries. So that's what I had circled here. 30,000 cups of blueberries. So you have to find out the number of hours it will take to consume this many cups of blueberries by the same bakery at the same rate.
Okay, thank you.
Okay, Jana, tell me, beta, what are you trying right now? Everybody is working on it, so just
I don't know. I got an answer. Okay, but like I think I did it really wrong.
No. First of all, take it out. Keep in your mind, it's you who do it right, okay? Don't doubt yourself. It says eat a blueberry. Slowly speak. So that nobody gets mad at that. Okay, per kilometer. Fine. How many hours? Okay. Okay?
What's the furthest up or what was it?
4 cups, 1 hour.
These are both cups and these are both hours. And so I'm looking for hours.
So, I'm not as tech savvy as you guys. Let me use this one. So, okay, so here, 800 blueberry pies, 1 hour. That's the rate we give to us. And then, every blueberry pie needs 4 cups of blueberry. Okay, this is a rule of thumb. So you might want to pay attention to this one also. Whatever you have to find out, you will write on this side. So like if you're writing an equation, right? We have to find out for 30,000 blueberry cups, how many hours we need, correct? So you'll always put it on this side so that you can calculate. What do we know here? 4 cups of blueberry needed for one blueberry pie. And this guy is making this many blueberry pies every hour. So every hour, how many cups of blueberries are used? This many?
Yeah.
So it uses this many blueberries per hour. So you are saying, okay, 3,200 blueberry cups are used per hour. Okay? 1 blueberry cup is used in how much? 1 over this thing from here, right? This much. This many cups in 1 hour. In one cup will be taking how much time? You can divide, right? That is how you get a lesser value. So 3,200 blueberry cups needs 1 hour. 1 blueberry cups needs 1 by 3,200 hours. What we are talking about? This many cups. So 30,000 cups will need 1 by 3,200 into.
Wait, why is it 3,200?
Because 1 blueberry pie needs 4 cups of blueberry, and the bakery makes this many blueberry pies every hour. So 1 cup needs this many. 1 blueberry pie needs this many cups. This many blueberry pies will need how many? This into 4.
Oh, okay.
So you are consuming at this rate. So to consume this many, yeah. So this is a story. Okay, there is no formula here. Let me do it on the board for everybody's benefit, and then I think then you will relate. Oops, but okay, so it's okay. I might have said in a very cryptic way. Let me see who all are with me right now. Anybody got any answer? Apart from Praneeth, Ritika, Vishal, Samriddhi, Ananya, Ria, what's happening? You guys are not. I was giving you guys some time and helping one of the kid here. I thought you guys will finish it. But still waiting? What's happening? Yes, Samriddhi.
9.4.
9.4? Okay. So this is not a difficult one. It's just about how you think. Now let's think. Is everybody with me right now? Can I have everybody's undivided attention? Okay. So here, what this question says is the bakery bakes this many blueberry pies every hour. Okay. Tomorrow they start ironing clothes. That is a different story. We are not talking about it right now. They are baking this many blueberry pies every hour. Now for baking that many blueberries, they need blueberries, right? For baking that many blueberry pies, they need the ingredients, right? That is coming from this information. Every blueberry pie needs 4 cups of blueberries. Yep. So in 1 hour, what they are consuming? How many cups of blueberries they are consuming? 1 blueberry pie needs 4 cups of blueberry. See, there's no math here. We are just relating to real life. Okay, one blueberry pie needs 4 cups of blueberries. This guy is baking this many blueberries every hour. So in 1 hour, they are baking 800 blueberry pies. And every blueberry pie needs 4 cups. So this into 4. This many cups of blueberry they would need. Correct? Yeah. Without that, how will they bake? Yeah. So they need 800 into 4, 3200 blueberry cups. I'm sorry if I'm using acronyms. I'm just trying to save some space and time. So now we know that, okay, for 1 hour of baking, this many cups of blueberries are used. Okay, for 1 hour of baking. What is the question here? The question says, how many hours it will be able to, how many hours it will take to bake this many cups of blueberry. Now we have a relationship given to us that every hour of baking needs this many cups of blueberries. So how many hours it will take to bake this many cups of blueberries? Obviously for making the pie. So if any of you remember, I had asked this question to many of you, that who is mother of math? And I forced you guys to believe that it is English. So right now the mom is helping the baby. Okay, we are not using any formula here. Whatever we know, we are just applying that. Okay, 3200 cups of blueberries would be needed for 1 hour of baking. 3200 cups of blueberry. Let's use English only for solving this problem. Will be 200 cups of blueberries will be needed for 1 hour of baking. The question is, for 30,000 cups of blueberries, how many hours? That's the question, right? So whatever you have to find, always put in the right hand side when you are using English for solving things. So, okay, let's find the value for 1. Okay, 3200 cups of blueberry is baked in 1 hour. If I have to find out 1 cup of blueberry is baked in how much hours? How many hours? 1 over 3200, right? It will take much less time, right? 3200 cups is taking 1 hour. So 1 cup will take much less than that. Yeah? Is everybody following me, or I'm just teaching myself? Khushi, am I making sense, beta? Nanya, Sarah, Neil, Vishwa, everybody? So I'm just using English, okay? I'm trying to stay away from math as much as I can. So 3200 cups of blueberry can be baked in 1 hour. So 1 cup of blueberry will take much less time. That is when you end up dividing it. Now we know that, okay, 1 cup of blueberry can be baked in this many hours. If I had to bake 30,000 cups of blueberry, how much time will it take? Whatever it takes for 1 cup of blueberry, multiply that with 30,000. Yep. If I can read 2 books in 1 hour, how many books I can read in 5 hours? 2 books in 1 hour. In 5 hours I will read 2 into 5. Right? Similarly, 1 cup of blueberry can be baked in this many hours. 2 cups will take it into 2. 5 cups will take this into 5. 10 cups will take this into 10. That many hours? This many cups of blueberry. Multiply with that number. So, see, the idea here is, when you are dealing with this kind of situation, when you know for 1 value takes that much, for some other value, what you'll do is, you'll find, okay, how much it takes for 1 unit, right? Let's say you have to find out how much time it takes for driving from here to Houston. What do you find out first? Okay, what is the rate at which I'm going? 70 miles per hour? So 1 hour it takes for 70 miles. Or 70 miles can be done in 1 hour. This many miles. How many hours? Right? So you always find out for a unit and then you multiply it by that many numbers that you're trying to find out for. Is it okay, or looking or sounding cryptic to any of you? Ritika, is it okay, beta? Neil, Sarah. Anything that is not clear, I can explain it one more time. It's perfectly fine. I'm just trying to make sure that I'm not forcing you guys to believe me. Khushi, Ria, everybody okay? Samriddhi okay? Now, from this one you got nine. We have to find to the 10th value, right? So that's what we are doing. Let's sort it out first. 0, 0 gone. 300 divided by 32. That's what we have to do. So, if it was 320, that would have been a perfect 10, but it is less than that. 288 would have been a perfect 9. So, it's 12 more than this. So, 12 by 32, you'll find out how much it is. 12 by 32. Yeah. 4 3 is 12. 4 is 32. 3 by 8 is 8. Whatever. 8. 4 is 32. 8 3 is point. 8 3 is 24. 6. 8 7 is 56. 0.37 which will round to 0.4. So this is 9 and this is 0.4. 9.4. Yeah. I mean, some my dirty technique, but you guys have a better approach for doing it. Anyways. Alright. Okay. So shall we move on? Or everybody is exhausted with this stupid problem? So moving on. Okay. Let's go to the next one because we have to be progressive in nature. Keep progressing. Now the next one. Specific gravity is the ratio. Specific gravity is the ratio as a decimal of the density of substance to the density of water. Wonderful. See, these are the techniques the examiner uses for getting people scared. Okay, let's not get scared. Let's promise ourselves that we are brave, more brave than much more brave than the techniques used here. Specific gravity is the ratio as a decimal. Specific gravity is the ratio, comma, as a decimal of the density of a substance to the density of water. Wonderful. Let's not worry about it. We'll come to that. We'll come back to that sentence, okay? Because when you're dealing with this in the exam, your energy will go in reading the sentence to draw your own interpretation from that. Oops. Specific gravity. I'm just saying specific gravity. Okay. Specific gravity, SG, is the ratio. It's a ratio. If I say ratio, right? Ratio is x by y. Okay. Now x will be something, y will be something. Let's see what are those x and y. As a decimal. Okay, so whatever it comes, it is represented in the decimal form. Something like this. X point y or something. Okay, let's not worry about it. Specific gravity is a ratio as a decimal of the density of a substance to the density of water. Okay, now it is density of substance by density of water. Now, when I read this sentence 2-3 times, I'm getting little more comfortable with the sentence. Okay, specific gravity is the ratio as a decimal. So whatever value comes from this is printed in the decimal form of the density of the substance by density of water. Okay. So this density, density you can measure, right? This many kilograms per cubic feet or whatever. So let's not worry. Noah, you are 8 minutes early for the class, beta, okay? Join after 8 minutes, otherwise you'll be scared. So it says specific gravity is is the ratio in as a decimal, meaning it's represented in decimal form. You do the calculation, you find out something in the decimal form, okay? Of the density of substance, density of a substance to the density of water, meaning if I say density of substance is something, density of water is something, these two are related, not related terms. But specific gravity says, okay, you compare the density of the substance to the density of water. This is what this question says, okay? I'm not trying to justify that physics theorem also, okay? I'm just saying that, Noah, you are early for the class, beta. You have to join after 7 minutes, okay?
Yeah, I was gonna ask that.
Yes, yeah. Reading one last time. Specific gravity is the ratio as a decimal of the density of substance to the density of water. I have muddled the water enough. Let's move on. Density is the ratio of mass to the volume. So if somebody says what is the density? Density is mass by volume. This is what the question is also saying. Density is the ratio of the mass to the volume. The mass of 760 gallons. The mass of 760 gallons of fuel is 2325 kilograms. A single gallon of water has a mass of about 3. So this is one information, this second information. See how interesting it is getting now. A single gallon of water, 1 gallon of water has a mass of 3.8 kilogram. To the nearest tenth, what is the specific gravity of jet fuel? Interesting. I know everybody is scratching their head and there is a reason for it, but don't do it much. Okay. I'm reading the question one last time. Now we have so much information on the board. Let's connect the dots. Specific gravity is the ratio as a decimal of the density of a substance by density of water. Okay. Now what is density? That is described here. Says density is the ratio of the mass, kilogram, whatever in weight, right? Kilogram or pound, whatever we use. Density is the ratio of mass is to volume. So if you know any substance's mass and the volume, you will divide mass by volume and you get the density of it. It says now the mass of 700 gallons of jet fuel is 2325 kilogram. So this is the guy we're talking about. Jet fuel. 700 gallons of fuel is weighing this many kilograms. And it says a single gallon of water has a mass of 3.8 kilogram. Find out the specific gravity of the jet fuel. How does it sound to you guys? Cryptic? So, okay, see the calculation here is not difficult, okay? Calculation is not difficult here at all. I want you guys to use the remaining 7 minutes to think about it. Okay? Yes, ma'am. Okay. So, what you guys are thinking right now, that is more important for me. No, see, this is, if I'm pretending to be, super intelligent right now, which is not the case any which way. Rudraksh, you are here, but you are not here. Sit and wait for your turn. No, that I have to keep telling these younger ones, okay? Because otherwise they will keep making sound. So, what I was saying was, this is a very normal scenario. The calculus is not difficult here. There is a trap. that is created for us to get lost. And I'm just curious to know who all have fallen into that trap. Everybody? Yeah, tell me.
Is gallons the volume or is it density?
Yeah, that's what it is.
No, which one will it be?
Kilogram will be weight. Kilogram or pound, that will be.
No, for gallon, because 1 gallon of water has 3.8 kg. So 1 gallon of water, would that gallon be a density or would it be the volume of it?
The gallon is always the volume. See, gallon is the space it takes. If you remember.
Do you want the answer or?
Yeah, tell me the answer.
Okay, answer.
So all the kids from level 1, just hold your horses for a few more minutes, okay? Whatever you are hearing, don't worry about it right now. Otherwise, you'll be super scared. Okay, so let me just give you guys some clue, and I will leave you guys with that clue. Can I have everybody's attention for 2 minutes, except the younger ones? So here, this one says specific gravity of any substance is density of that substance by density of water. What is density? That is what this one says. Density of anything is mass divided by volume. If you know the mass or the weight, if you divide that by volume, that will give you the density of that thing. So if you have to find out specific gravity, how to find? You have to find out density of that thing by density of water. And this is the formula for calculating the density for anything. If you calculate density for this guy, you'll use this formula. If you calculate density for this guy, you'll use the same formula. Now, how do you find density of the substance? This is the substance given to us. This many gallons of fuel is weighing this many kilograms. So this is your gallon is volume, this is the mass. Put the mass, divide by volume. That will give you the density of this substance. That goes as a numerator here. Sit down, guys, and you are still not here. Class is going on. Please don't disturb the class. This is the water. 1 gallon of water has a mass of this much. So 1 gallon is the volume. This is the mass. So mass 3.8 by 1 will be the density of water. 2325 divided by 760 will be the density of the substance. Find out density of the substance, put in the numerator. Find out density of water, put here. And that ratio will give you the specific gravity of the substance. No flipping paper even. I want pin drop silence when I am teaching. Okay? So please. So that we can finish this class and then we can start for you guys. Okay? All the level 1 kids will start in 2 minutes. Just don't even say anything. So here, what I am saying is, this question doesn't have enough weight. There is only a trap. And that trap is because of this is a verbose question. Lot of words. You have to decode the words by breaking it down. Specific gravity is density of substance by density of water. What is density? This is the formula. Okay, let's find out density from here for the substance. Density of water from here. From this information, find the density of water. This density goes as numerator. This density goes as denominator. Done. And I did not do anything fancy, trust me. I did not have enough skill to solve this problem. I just decoded the English part of it. Whatever we read it a couple of times, right? You would have seen that, okay, this gentleman is reading it so many times. Because I was trying to decode it, extract all the information, convert that into a language that we all understand, and then apply the formulas. All about that simple formula. They have given the formula also. We just have to decode it and apply it. That's it. Yeah? Yeah. Ananya, Samriddhi, Biswa, Vishal. Everybody clear? Not clear? Okay. So, nothing cryptic, nothing complicated, but the word problems have the habit of getting people exhausted. This is where the effort goes.
I can't use my pencil.
Keep quiet. Because I am not even seeing you right now.
Okay.
Be quiet. Everybody quiet. So, we'll do more practice. Ultimately, it boils down to practice. Word problem is something that you will be able to deal with only and only if you derive or kind of decode or find your own trick for simplifying them. And one of the most hated technique is RAN. Read, analyze, then do it. So here, doing was the easiest part of it, right? As soon as we found that, okay, how do you find density? Oh, this is also given. The calculation was the easiest. How you relate is where the effort was going. Yep. Arush, you'll agree, right? This is what you were doing. Your effort also went for decoding it, right? Calculation was easy, correct? Alright, with that being said, I'll let you guys go. Let you guys as in all the kids from level 3. All the younger ones have to bear with me for one more hour.